All right, if you are back at this point, then you have worked out sample A, and I am hoping that you got a standard deviation of 2.16. In sample A, the mean was 20. That's important. You got to get that. And the magic number, what you get for the magic number? It's 28. It's 28. So the sum of x minus the mean squared, that's actually steps 2 through 4, 2, 3, 4. That gives you the magic number of 28. Okay? And the standard deviation is the square root of the magic number divided by n minus 1. Well, n, 1, 2, 3, 4, 5, 6, 7. N is 7. So n minus 1 is 6. So if you take the square root of 28 divided by 6, you get a standard deviation of 2.16. And if you didn't get it, like I said, I wish I could take a look at your calculator, but it's probably a parenthesis or something. So I'm going to work through sample B with you. This, last time we're going to go through every step. Okay, I'm going to kind of combine it on the calculator, and you just kind of work along with me, okay? So go ahead and do the mean. So the mean would be 5 plus 10 plus 15 plus 20 plus 25 plus 30 plus 35 divided by 7. All right. And if you do that correctly, guess what? You get a mean of 20. So isn't this interesting? Because here's what we're doing here on this problem that I should have given you some context. I am sorry. I just got excited about the calculator stuff. Here are two different classes that took a 35-point quiz. Sample A is 7 results and sample B is 7 results. If you just look at these two samples, which of the scores seem closer together? Sample A, yeah. You already know the mean now is 20. So it looks like the scores are much closer to the mean, 3 below and 3 above. Whereas on sample B, look at the scores. They're all over the place. Somebody aced it. Somebody got a 5. Like, goodness gracious, really? You got a 5? And the mean is 20. So on this data set, all right, the mean is 20. But what do you think about the standard deviation? You think it's going to be larger than 2.16 or smaller? Well, common sense would probably tell you larger, right? Because the data is more spread out. Well, let's go work it out. All right, so here we go. So you have the stuff right in front of you, and I have it written down, okay? And we are going to go work this out on the calculator. All right, so here we go. So we're going to do each data item minus the mean and square it. So 5 minus 20 squared, that's the first one, right? And then the second data item is 10 minus the mean and square it. You're always subtracting the mean, and then you're going to add this every time. Plus 15 minus the mean, square it. You'll get this down. Plus 20. Well, what's 20 minus 20? This is really silly. This is 0, right? But we'll do it just for practice. Okay? We got 3 more. Plus 25 minus 20 squared. Now remember, I made some mistakes on the last time, so be careful. Plus 30 minus 20 squared. Plus the last one, 35 minus 20 squared. And this is the magic number, 700. I need to see that. I don't need to see all the calculations, but you've got to write down the 700. Okay? So let's go back to the problem. And here's what I need to see. Whatever you want to call this. You can call it the magic number. Okay? So the magic number is 700. Okay? This is all you actually have to write down for me. Write down the mean Write down, because if you miss the mean, then I know that your whole problem's wrong. But I can still give you partial credit if you show me some other work. I can kind of figure out if you did it right based on the wrong mean. All right, I can tell. And then the standard deviation is the square root of the magic number divided by n minus 1. Well, n is 7, n minus 1 is 6. Okay, so let's do that. Let's do that. So, square root. Now again, if you're not sure, put it in parentheses. If you're not sure, type square root parenthesis 700 divided by 6, close parenthesis, and hit enter. Okay? If you did that correctly, you should have got 10.8. And yes, of course that standard deviation is much larger than the other one. It's 5 times as large. 4 times as large. Almost 5 times as large. Actually like 4.5. Okay? So hopefully that makes sense. The more the data varies, the more it's dispersed, the larger the standard deviation. Okay? And without getting into, again, if this was a stats class, I would talk to you about all kinds of cool stuff, you know, O-rings on space shuttles and tolerances of expensive cars versus cheap cars. That's why, you know, for example, you get in a Lexus and you close the door and you hear like a thunk, like a tight sound. That's because the tolerances on all the parts are much closer. They have much smaller standard deviations. That's why it costs more, because there's more time put into something like that. And the cheaper parts have greater tolerances and they rattle more, so the cars are louder and they break sooner and they maybe don't last as long. So that's just a really quick example. But okay, all right. So oh well, yeah, we already did it back here. We did all the work. So hopefully that and the calculator is what you needed, because gang, we are almost done. You've done all the hard work. Just a couple of questions and we'll wrap it up. So interpreting standard deviation. A professor has 2 sections of a math class, the 8:30 class and the 2 p.m. class. And he finds out that the mean score, okay, the mean score for the 8:30 class was 74%, and it had a standard deviation of 3.6. What does that mean, 3.6? Well, that's pretty low. So that means that most of the scores were what? Close to the 74 or spread out? They were close. That's exactly right. Look at the 2 p.m. class. 2 p.m. class also had a standard deviation of 2.4, but look at the standard deviation, 9.2. All right? So what would you say? What would you conclude? Okay? Well, hopefully you would say that, well, it appears that the scores, the test scores for the 2 p.m. class are much more spread out. Maybe some high A's and some low D's, you know, something like that. And you'd be exactly right, okay? You'd say in the morning class, and you would something like this, all right? In the morning class, the students probably have scores relatively close to the mean, okay? Very few high and very few low. They're all grouped together. A lot of low C's and high C's, or some B's and D's, but very few A's and very few F's. But in the other class, okay, they had a lot of high scores and a lot of low scores. Okay, it averaged out to a 74, but remember the standard deviation was 9.2. Guys, that's almost a full letter grade. That's a lot of, the grades are all over the place. Okay, and that's what this says. So be able to think and write about what the standard deviation means in general terms. Okay, and send me an email. Let me know if you're struggling. I sent you an email with a tutoring link, which they would love to walk you through standard deviation. But hopefully these videos helped. I broke it up into 3. I think you're going to do great. Have a great week. I'll talk to you again soon. Bye-bye.